So this is the problem statement. We are having 14 columns C1 to C16 with C6, C7, C10 and C11 of 600 by 600 dimension, while the remaining columns are of 500 by 500 dimension. The safe bearing capacity is 300 kilonewton per meter square and the allowable settlement is 0.01 meter. So this is the plan view of the base story. So using this we will be drawing our mat foundation, and this is the table showing the dimension of column C1 to C8, the dead and live load acting on it, and the materials used for the columns. And this is the same table for column C9 to C16. Now we will go to the safe software. We will create a new model. The unit should be in metric, and we set our design preferences. We keep both top and bottom clear cover as 50 mm and the preferred bar size is taken as 22 mm. We select grid, and since the base story dimension of the building was 18 by 18 meter, we first draw the base dimension, the grid line, and then we extend it to draw the mat foundation. So since the dimension was 18, we will be needing 19 grid lines spaced 1 meter apart from each other. So x direction and y direction both will be having 19 grid lines with spacing 1 meter each. Now we will define the materials. M40 and IISc 500 are the two materials. We give the defined values. Now we define the rebar material. IISc 500. Now we will be adding the slab properties. We will be defining the property of mat footing, and the slab material or the mat footing material is M40 concrete, and the type is defined as mat, and initially we are assuming a thickness of 500 mm. Now we have to define the columns. There are two columns, but both having the materials of M40. First type will be having a dimension of 500 by 500 mm, and hence we will be naming the column as column 500 by 500. Similarly, we will be defining the second type of column having dimension 600 by 600 mm but the same material of M40, and we will be naming it as column 600 by 600. Hit OK. Now we have to define the soil subgrade properties. There is already a soil property defined, so I will be modifying it, and the subgrade modulus is 3 into 10 power 4. Now I will be moving to lot patterns, which is fine. Then lot cases, both are analyzed as linear static, since we are doing the linear static method, so it's fine. And now we need to set the lot combinations. You have to select both dead and live load, and for the first ultimate strength load combination we have to hit a scale factor of 1.5 each, and we need to select strength. Now we need to define the second load combination. Both dead and live load needs to be selected, and this is for the service criteria, for which the scale factor is 1 in both. and we need to select the normal, initial as well as long term service radio boxes. Click OK. Now all the materials and sections have been defined. Now it's time for drawing the foundation. Make sure we have selected the mat footing from the property type and we start drawing. Now we have drawn the mat footing. Now we can exit this dialog box. Now we need to extend this mat footing by 2 meters in all directions. So we need to select the mat footing first. So we'll be getting one area for selected text in the left bottom corner. Now we go to edit menu, edit areas, expand areas, and offset value is 2 meter or 2000 mm. And there we have our mat footing. Now it's time for drawing the columns. The property below is none, always, and the property above is the required column property. Height below is therefore 0 always, and the height above is taken as 2 meters. Now we draw the columns. Now this is the position of column 6 and this is that of column 7, so we leave both of them and now we move to column 8. This is the position of column 11 and this is the position of column 10, so we leave both of them and we move to column 9. So we have done drawing the 400 by 500 columns. Now we shift to 600 by 600 columns and draw the 4 middle columns. So we have completed drawing the columns. Now we need to assign the property to the rebar property, the foundation. So we right click the mat footing and set the rebar material to IISc 500 and hit OK. Automatically the rebar material for columns will be set as IISc 500. Now we need to draw the design strips. So strip layer A, that is in the X direction, and the width is 0.25 times into L. L is 18 meters, so it is coming as 4.5 meter. Since there is no limit for concrete design, we can take it as 4 meter in all directions. Now we can start drawing the design strips passing through the center line of each columns. Now we need to select strip layer B, that is in the Y direction, and the widths remain same. So we have completed drawing the design strips. Now we need to assign the loads as well as the rebar materials to the design strips. Loads to the columns and the rebar property to the design strips, and the soil subgrade property. So we are selecting the mat foundation, assign support data, soil properties, and select soil 1. Click OK. So the soil property has been assigned. Now we need to assign the rebar properties to the design strips. So we have assigned the rebar property to the design strips also. Soil property has been assigned to the mat footing. The rebar properties has been assigned to both mat footing as well as the columns. The column property, the slab property has been assigned to the respective elements. So the assignment part is also complete. Now we need to assign the loads, dead loads and live loads acting on each of the columns. For assigning the loads, we need to select the columns first. We need to select each columns one by one. First, we will be assigning the dead loads for all the 500 by 500 columns. Set the dimension, load dimension into 500 by 500 mm. Now we will assign the live loads to all the 500 by 500 columns. We have completed assigning the loads to all the 500 by 500 columns. Now the 4 600 by 600 columns are remaining. So this was column number 6, C6. We will begin with live loads. C6 live load is 2797.8, and we have to change the dimension of load to 600 by 600 mm. That's the only change we need to make. Now we have to repeat the process for the remaining 3 columns. It's live load for C7, which is 2579.8. Now C10, C10 live load is 2644, and C11 live load is 2709.1. So we are left with assigning the dead loads acting on the 600 by 600 columns. Change the option to dead, and the dead load acting on C6 is 5414.9. The dimensions are 600 by 600 mm, which is correct. Now we move on to C7. Dead load on C7 is 4977.2. On to C10. Dead load, size of load 600 by 600, and the dead load is of C10 is 5154.6. For C11, the dead load is 5191.3 kilonewton, and that's it. We have done with assigning the loads, both dead loads as well as live loads acting on all the columns. So all the assignments are complete. Now we can analyze or run the model. As we assign the soil property, the rebar property to the columns, slab and design strips, and load assignments on the columns are also complete. Before that, we need to save the file. Now it is under analysis, and this is the analysis result, which shows the displacement due to dead loads in millimeter. So this is the deformed shape. So now we can run analysis and design. After that, we can display the punching shear ratio. So we can see that over almost all columns are having the punching ratio as greater than 1, so we need to redefine the slab thickness. So we unlock the model, go to define slab properties, modify, change to 900 mm. Run analysis again, and we design again and display the punching ratio. And now we can see that only the middle 4 columns are having the punching ratio as greater than 1. So it means that we still need to redesign the slab, or we need to still increase the slab thickness. So again, unlock the model, go to define slab properties and modify the thickness to 1200 mm. This should do it. We run the analysis once again. This is the deformed shape due to dead load in mm, and we display the punching shear. Here we can observe that we can see that all the ratios are less than 1, so it means that the design is safe now. It is safe against punching shear. So here we can see the moment to two combinations acting on the slab or the mat footing. This gives the value in kilonewton meter per meter into 10 raised to 3. Similarly, we can observe the shear values. Now we need to design the slab, strip based, impose minimum reinforcing, and click apply. So this shows the reinforcement intensity at different points of the slab, and to get the values at different points we need to just toggle over each or hover over each of the points. This shows the crack widths developed at different points at the bottom face of the slab, and we can change the combinations here. So we are done with the design and detailing of the foundation as per the problem statement. Here we can see the detailing properties. Now we have to run the detailing before getting the detailing properties, and the detailing has been generated after going for the detailing option. So this shows, double click in the rebar table shows the detail of the rebar materials, individual slab views, gives the rebar plan for all the bars, the bottom face as well as the top face, and this completes the foundation design as per the problem statement. We need to save, and that's it.